Good morning, everybody. This is Math Foundations Pre-Calculus. It's a section on polynomials, and this is just the end of the division part. Welcome. I thought I had something really important to say, and I promised I wasn't going to ramble this one. Sorry, my bad. All right. What are the rules for dividing a polynomial? So remember, all right, poly, meaning many, by monomial, meaning one term. Please include what happens to the number of terms and the digits. Well, you know what? I'm just going to steal question number 2 over here, 20, and I'll show you the magic. And it's almost nothing new. 3 plus 10x squared over x. Okay, so this is the part, polynomial 1, 2, 3, monomial 1. In Math 10, that's all we have to worry about. Pre-calculus, maybe 30. You get to have multiple terms on the bottom. I don't want to talk about that because it won't work. Here's the deal. All you got to do is split this up. And there's a number of ways to do it. I'll do it the right way. And then when we do the questions down here, I'll kind of show you a cheat. What this means, and we talked about this in the last unit, is this division line, I don't know, fraction bar, whatever you want to call it, means it's this whole thing divided by this. So each and every one of those terms gets divided by 10x squared. Oh, I'm not even going to lie to you. All I'm going to do, I was going to rewrite it, but why? Whoops. So all I do is rewrite it so that I've got the divisor, yes, under each one of them. Because I find if I don't do that, I'll divide like the first one and then I forget about it. I think you can handle this. So what are the rules? 1, right? I'm going to say denominator because it's a fraction form, so that's a bottom number. Oh, not number, bottom term. Actually, I should have done it the right way because this is confusing me. So what you get is 3 individual division questions. So we do the division. 20 divided by 10 is 2. X to the 4 divided by x is going to give me x3. The cool thing is the signs come down. 50 divided by 2, oh, sorry, signs come down. I should write it. So it's going to be 5x squared. I'm subtracting my exponents. Plus 10 divided by 10 is 1. X squared divided by x is x. That's it. So if I went through that a little too fast and you're like, I don't remember how to do division, watch video 3.1 and 3.2 because we do a lot of it. Probably just 3.1 will be enough. Divide each term. Number of terms in answer is the same as number of terms at the start. So if I've got 3 terms, 1, 2, 3, my answer should have 1, 2, 3. If you divide by a positive, the signs stay the same. Okay, I'm gonna wait. I bet you know what I'm about to write next. If you divide by a negative, your signs all switch. Um, Actually, I'm going to go back and put a little star at number 3. That is going to be right. So if I start with 3 terms, I'm going to end with 3 terms, or start with 2, I'm going to end with 2. That's going to be right 99% of the time. If I try really hard, I can make it where that changes. And I'm going to take a peek. I don't see that happening on there. The only time it has happened, so for example, if I have 5x plus 15x, whoops, over 5x. Well, the only reason my number of terms is going to change is if these are like terms and I can add them to start with. But honestly, the software doesn't do it, and I don't remember all the time to do it. But just every once in a while. Anyway, that's enough. That's all there is to this. Okay, so let's try. We did this one, so not doing it again. And I think you guys can handle it. I don't know that not having the line all the way across made such a difference. So that's literally all we do. And then we do that part. So 20 divided by 4 is going to give me 5, and K7 divided by K3 is going to give me K4. So 5K to the 4th plus 4 divided by 4 is going to be 1. K5 divided by K3 is going to be K squared. Plus, bring down my sign, 24 divided by 4 is going to give me 6. And in this case, the K squared are going to disappear. So that's it. I think at this point, you should pause the video. You can probably do the rest of the assignment and then just check the answer key. Or you could check the solution key, which is the written out, which is essentially a copy of this thing. Or you can watch the video. I don't know. Okay. There we go. All right. And then, oh, this is a good question because I catch people on this all the time. 10 divided by 10 is 1, n squared. 3 minus 1 minus 5, n squared divided by n is going to be n. And everybody stops. No, 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 no. 10 divided by 10 is 1. Remember I said if there's 3 terms when you start, there's 3 terms when you finish. Oh, the other thing I do is I go sign check, yeah, matchy, matchy, we're golden. Because for me, that's the mistake I make most of the time. 12m, 12m. I should have made these harder. 72 divided by 12 is 6. M to the 4th minus 4, m3 minus 10, m squared. See? You'd learn those initial rules with dividing a monomial by a monomial. This, although it looks scary, is like super easy. All right, next page. And clearly, I left way too much space on these pages. Oh, 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 look at this. Look, look. Sorry. We're dividing by a negative, so when I make sure, when I rewrite it, bring that negative along. So 4 divided by negative 4 is going to give me negative 1 n squared. 28 divided by negative 4 is going to give me negative 7 n, and 24 divided by negative 4 is going to give me minus 6. I think I'm right, but it's 1, 2, 3, 1, 2, 3. My terms haven't disappeared. But most importantly, these were all plus. I divided by a negative. These all switch to negative. It's those really quick, easy checks at the end to make sure you're golden. So I can see here, I got to be careful with my signs again. So 48 divided by negative 8 is negative 6. Now we've got two variables, but hey, that's all right. We just do them one at a time. H to the fourth divided by h is going to give me h cubed. N to the fourth divided by n squared is going to give me n squared. Now a negative divided by a negative is positive. Oh. Use your calculator. There's two ways. You can just say, all right, 2 divided by 8, which 0.25. You already knew it was like a quarter. So we'll just use 0.25. If you want, you can go 2 goes into 2 once, 2 goes into there 4 times, which gives you a quarter. If you're fraction happy. All right, my h is h3 divided by h is 8 squared, and the n squared disappear. Now I've got 40 divided by negative 8, which is going to give me minus 5. My h's cancel this time. And what do I do with the n? Let's see, we got n to the 1 minus this. So I'm just going to go n to the minus 1. That would be okay. If you wanted to put the 5 and put the n on the bottom, that's, hold on. Yep, there weren't, the question said divide. It didn't say anything about whether you wanted positive exponents or not. It's pretty easy. I hope you're finding it that way. Oh, got a little ahead of myself. These questions aren't always 3 terms. I have no idea why all the samples are 3 terms. 24 minus, whoopsies, 24 divided by 8 is 3. Ooh, this one's fun. That's k squared. And that is k fifth. So this is 2 minus 5. That's going to give me k minus 3 minus 16 divided by 8 is 2. 4 minus 5. 4 minus 5 is minus 1. So k to the minus 1. And 48 divided by 8 is going to give me plus 6. K minus 5, so minus 2. Ta-da! That's the easiest answer. If you wanted to, let me put it this way, an equivalent answer. 24 divided by 8 is 3. I have more k's on the bottom, so I can put k3, right? Minus 16 divided by 8 is 2. I have more k's on the bottom. How many more? I got 1 extra. Okay. And 48 divided by 8 is 6. I have, again, more k's on the bottom. So I'm thinking in terms of canceling, that I have 3 k's on top, 5 k's on the bottom. Oops. K squared. I'm not really fond of either of those answers. They're both right. Neither of them look pretty. So if you like negative exponents, good. Probably easier. If negative exponents drive you crazy, this works too. All right. Oh, okay. 2b to the 4th divided by 2b. So it's going to give me b 3 plus b3. Oh. B3. Okay. Well, I'll finish it. So B3 and a B3 and a B3 does not give me B9. I'm not multiplying. It gives me 3. B3. Or if I did this mathematically correct and I was paying attention, and clearly I put this in the end to show you this, these are all like terms. So I can actually put them together in the first step. So 2 plus 2 plus 2 gives me 6 b to the 4th divided by 2b. 6 divided by 2 is 3. B to the 4th divided by b is b cubed. And bada boom, bada bing, I was done faster. But sometimes you just get into this lovely little habit. You just write your step, you do the division, and go. So that goes back to the second or third rule. If there's 3 terms here, you should have 3 in your answer. Well, it's an exception. Here's the exception when you can take some of the terms and put them together. All right. Oh, got a little bit of review down here. I suspect that means I believe that you can do these questions already, so I throw these in. So finding square roots. Excuse me. Dream out. 175. Okay. It ends in 5, so I know it divides in there. So 175 divided by 5. Okay, so it's 5 times 35. 5 is prime. 7 and 5. Okay, so we're asked for a square root, which means we circle sets of 2. So that means this and this. So when you do that, this pair, you take the square root, comes to the outside. This is the leftovers. If you, yep, nope, I was going to give you another explanation, but you don't need it. But just remember that from every pair, when it moves to the outside, it's like taking the square root, so only one goes to the outside. Ooh, 324. I have no idea. I know it's an even number, but I'm going to guess. 324. Put it over there. I'm going to try 16. Nope. 324 divided by 8. Nope. All right. 324 divided by 4. 4 times 81. Okay. I could have started by, dividing by 2, but I was trying to be lazy. 2 and 2. 81 is 9 and 9. 2, 2, 3, 3. 3. So in this case, everything is paired. So it's pair of 2s, pair of 3s, pair of 3s, which means there's nothing left underneath the root sign. So 2 times 3 times 3. Again, 1 from every set comes into my answer. 2 times 3 is 6 times 3 is 18. And I can check. I can just go square root. Whoa. Try that again. Oh, wrong button. Square root 324 is just plain old 18. So I know that this is right. So there's no root sign. So sometimes, like this one, when you take the square root, you're going to get something left under the root sign. You know what? Just for fun. All right, move my camera. There we go. If we do the square root of 175, see how it's a decimal number? I think there's calculators out there that are fancy enough that'll actually give you like the root sign doodad, like will take you right to here. But this at least tells me that there's something left under the root. I don't know what it is, and that's fine. But so I know there's something in the root sign. This one, when I did the square root, it was just plain old 18. Now I've proved it, but there's nothing under the root sign. So last 2, 16. It's 4 times 4. We know the square root of 16 is 4, but I like you to prove it. 4, and 4, 2, 2, 2, 2. Circle, circle. So my square root is 2 times 2 is equal to 4. My point is, I want you to be able to do this to show it. I know they probably know the answer, or you can use a calculator, but when we start using variables of square roots, which is the next section in factoring, you need to know the pattern well. This is 8 times 4. 4 times 2, 2, 2, 2, and 2, 2, and 2, and 2. There's a pair, there's a pair, there's a spare. 2 times 2, root 2. So just so we're good, this is this one, this is this one, this is this one. So that's going to give me 4 root 2. Now, yet another one of those, just for fun. All right, so where am I? Square root 32. Square root 32. Okay, so 5.65. 5.6, good enough. If I take this and I take the square root of 2 and I multiply it by 4, ta-da! I get exactly the same number. And you're like, so I can check that this is what I'm supposed to have because they both have the same decimal thing. Root 2. Oh, they even allowed me to just do it in order like that. That's because, I don't know if you can see it, put it in better light here. DAL. I think it's called direct algebraic logic. I don't know. The DAL calculators allow you to pretty much type stuff in exactly how you see it, and it simplifies. Anyway, end of the video. Time to go to work for the day. Have a spectacular morning, afternoon, day, life. Can't get this to stop. There we go. Bye.